Hello students. So in this video I am going to tell you about the lenses, which is a part of our chapter, that is refraction and dispersion of light. So this structure lens you must have seen in the laboratory or in your house. Now if I talk about the definition of the lenses, so lenses are the transparent medium bounded by two surfaces of which at least one is spherical. So there are various shapes of the lens, and in each shape you can see that one of the surface is spherical. If I talk about this shape, this is the equiconvex or simple convex lens. These are plano-convex, biconvex, converging meniscus. Similarly, in the concave, this is the simple or convex lens, concave lens, which is also known as equiconcave. Plano-concave, this one is plano-concave, this is biconcave, and this is the diverging meniscus. So in each of these shape, you can see one of the surface is spherical. Now the most common type of lenses which we are using generally is, one is the convex lens. As you can see, this is the convex lens and this is the concave lens. So what is the basic difference between these two shapes? So if you can see here, the thickness at this middle part of this lens is more, whereas at the edges part this thickness is very less. That means this edge is thin. Whereas if I am going to compare this lens with the concave lens, so in the middle part this thickness is less and the thickness at the edges is more. So this is the concave lens and this is the convex lens. Now if I'm going to show you the real picture of these lenses, so you can see this is the convex lens and this is the picture of the concave lens, and you can watch their thickness of the edges also. This is very thin, whereas this edge you can see is very thick. So this is the concave lens and this is the convex lens, which is broader at the center part or the middle part, and this is thinner at the center part. Remember, I have already told you that convex lens is also known as magnify lens, and you can see the magnification done by this convex lens. So this is the real picture. Now convex lens is also known as converging lens, whereas the concave lens is also known as diverging lens. Why it is so? Because you can see in the converging lens, the light which is going to fall or which is going to pass through this convex lens is going to bend inward. So this is known as converging. Whereas in the case of diverging lens, the light which is passing through this lens is going outward. That means it is diverging. So this is the basic difference between these two lenses, and on the basis of these two property we are going to divide it into the converging and diverging lens. Now there are various terms that are associated with the lenses. So remember, if I talk about these lens, so this is the shape of the convex lens and this is the shape of the concave lens. And keeping these spherical surfaces, so you can see this is the spherical surface, one spherical surface of the convex lens, this is the other spherical surface of the convex lens. Similarly, here also you can find these are the spherical surfaces. Now, if we are going to draw or we are going to develop these edges into complete sphere, so in both side we are going to get, in this both situation, both type of lens, we are going to get two complete virtual spheres in the both type of lens. So here you can see this is the one virtual sphere and here you can see this is the one virtual sphere, and here also same spheres are available if we are going to draw or develop the edges into complete sphere. Now you can see these are the center of the these spheres, so which is also known as center of curvature. So remember, this is the C1 point which is the center of curvature of this sphere, and this is the C2 point which is the center of curvature of this sphere. Similarly here also you can find this is the C1 or this is the C2, which is the curvature, center of curvature of these two spheres. So first term you have to remember is the center of curvature. Now if I talk about the next term, which is known as principal axis. So what is principal axis? So this is the line which is going to join the these C1 and C2, that is the center of these two spheres. So this is the thing. And similarly here also, this is the principal axis, which is again, so these principal axes, these are common in both type of lens, whether it is concave or whether it is convex lens. Now the third term which we use is the optical center. So this point you can see placed in the center of the lens is known as optical center, and similarly here also this is the optical center of the concave lens. So what is optical center? So optical center is a point which is available onto the principal axis, remember, which is available onto the principal axis. In both the lens you can see this is the O point, this is O point, which is optical center, and this is the point from where if the light is going to pass, whether it is traveling straight, whether it is entering in this manner, diagonal manner, so if the light ray is passing through this optical center, so it is not going to deviate. So that is the thing. So that is the optical center where deflection is minimum, and minimum I would say it is almost negligible. So this is the point, you remember. So optical center is a point on principal axis where deflection of the light or deviation of the light is minimum or almost negligible. Now there are different terms related to the lenses like principal focus and focal length. So what is principal focus? Remember, in the case of convex lens, principal focus is a point onto the principal axis where all these rays which after the bending is going to meet. So this is the point that is known as focus, which is denoted with letter F. So here in the convex lens, all the rays after deflection or after bending inward will meet at this particular point, which is available on this principal axis. So this is principal focus. Similarly, here also in the concave, this is the focal point or focus. So this focus is the point from where the ray of light appears to come from after passing through this lens. So this is the focal point or focus of the concave lens, and this is the focal point or focus of the convex lens. Similarly, if I talk about the focal length, so what is focal length? It is the distance between the optical center and the focus. Similarly, here also you can see this is the focal length of the concave lens. So remember, focal length is the distance between the optical center and the focus. So these are the terms which are important for understanding the ray diagram of the images formed by the lenses by keeping the object around it. Now let us talk about the path of ray incident at different point of convex lens and how it is going to pass through the lenses like convex lens. So here you can see in this diagram, this is the incident ray which is coming parallel to the principal axis. So in this situation, the light ray is going to bend and will pass through the focus point on the other side of the lens. Similarly, if this is the ray and these are the ray at which are coming parallel to, so they are going to bend and they are going to pass through this focal point. So what about the ray which is traveling just onto the principal axis? So remember, when the ray is coming directly following this track of the principal axis, so it will not deviate, because and at the optical center, when it is going to pass through optical center, it is not going to show much deflection, so it will travel straight. Now if the line of ray line is coming in this manner, that is diagonal to the crossing the optical center, because at optical center no deflection is there, so this ray will pass directly without getting deflected. So this is the direction in which this incident ray is going to pass through the convex lens when it is going to fall upon this optical center diagonally. Now if the ray is moving like this and it is passing through the focus point which is onto this side of the lens, and then when it is crossing the optical center line, that this line, this is the center line of the lens, then it will bend in this manner and it will become parallel to the principal axis. So these are the three various type of positions how the ray is going to incident upon the convex lens, and these all things are going to be helpful for the next video, in which I am going to show you the ray diagram, in which I am going to tell you about how the light is going to pass through the lens and there it is going to form the image of the object which is kept onto the side of this convex lens. So that we will do in the next video. Okay.